This project aimed to calculate the distance a remote control car has to travel to be hit by a falling ball from an unknown height. In here we will cover two physics concepts, free fall and kinematics. Any object that moves only by the force of gravity is in a state of free fall. All free-falling objects on Earth accelerate downwards at a rate of 9.8 meters per second square, regardless of their mass. Also, free-falling objects do not encounter air resistance. Kinematics is a study of the motion of objects without reference to the forces that cause the motion. For this project, we used the third equation. As for the acceleration of the ball, it was assumed to be constant. First, we determined the speed of the remote control car. We recorded the car passing through the three tiles. For a constant speed, we allowed the car to speed up to its maximum before the recording time it took to pass the tiles. Then, using a video analysis system app, we determined the time was 1.67 seconds. Here, we show our calculations to determine the car speed. The three tiles measure 2.74 meters. This was divided by the time, which is 1.67 seconds, giving us a speed of 1.6 meters per second. Go! Our next calculation was the time it takes the ball to hit the ground. We determined the place where the ball will constantly fall, and then we determined the time it will take it to hit the ground. Like in the previous calculations, we recorded the ball falling and we used a video analysis app to determine the time, which was 1.07 seconds. Then, using the kinematics formula, we calculated the unknown height from where the ball was falling. This was 5.6 meters. To this height, we subtracted the height of the remote control car, and then recalculated the time it takes the ball to fall. The total time was 1.058 seconds. After obtaining the time it takes for the ball to hit the car, we calculated the offset distance. We used the car's constant speed and the time it takes to get hit. And here's our final calculation, which gave us 1.738 meters. We marked the point where the ball fell, and from there we measured 1.73 meters. We used a cone as a reference. When the car reached the end of the cone, we dropped the ball.